Hi everybody, this video is going to talk about lesson 9.3, which is special right triangles, because we need these triangles to go to the unit circle. So remember that SOHCAHTOA stands for sine is opposite of hypotenuse, cosine adjacent over hypotenuse, and tangent is opposite of adjacent. Then there are some typos here, so excuse those, cross those off. When we talk about sine, we talk about the sine of theta, and we use theta to talk about an angle. So for instance, if this is my theta down here, then my sine is opposite over adjacent, that is 3/5. If we talk about the cosine, it is the adjacent over the hypotenuse, that's 4/5. And if we talk about the tangent, that's opposite over adjacent, that's 3/4. Notice also that the tangent is 3/4. This one is 3/5. This is 4/5. So if we put the sine over the cosine, that will give us the tangent. And sometimes that's helpful to have that in our brain, so we remember how to do that. Now, this is a 3/4, and we need to now translate down to, well, what if it's a 1 instead of a 5? And so what if a hypotenuse is 1? Maybe before we do that, we need to get back to what if a side is 1. So for instance, if this is a 45, 45, 90, if this is a 1 and this is a 1, do you remember what this is? This is going to be radical 2. And on a 30, 60, 90, let's say that this is 1 and this is 2, then this is radical 3. You don't have to memorize those. You can get those with Pythagorean theorem, but if you have them memorized, it just makes it a little bit quicker and easier to access that information. And this is something that you spend a lot of time in geometry talking about. So if this is true, then that means we take, to get to the hypotenuse, we take the leg times radical 2. Or to get from hypotenuse back, we will take the hypotenuse divided by radical 2. So what we need to do now is talk about what if the hypotenuse is 1? That's called a unit triangle. So if this hypotenuse is 1, we need to divide by radical 2 to get over to this side. And we spent some time in our classes talking about how you're not supposed to have a radical in the denominator. So this is actually radical 2/2. So if you have a hypotenuse of 1 and it's a 45, 45, 90, then the two legs are going to be radical 2/2. Okay, what if it's a 30, 60, 90? Well, again, this side is half as long as the other, so this one is 1/2. And this side is radical 3 times as long as the short leg. And once again, you don't have to memorize this. You can use the Pythagorean theorem, but it just will make it a little bit easier if you do have it memorized. This one is the same triangle. It's also a 30, 60, 90. I didn't write it on here, but this is a 30, 60, 90. So this is my 30, and this is my 60, and this one is 45, 45, 90. And again, this one is a 60, and this one is a 30. And so we just took the triangle, put it on its side. So this is still 1/2, and this is still radical 3/2. So now what we're going to do is we're going to take these and put these in a circle in just a minute. But before we do that, let's talk about sine, cosine, tangent. So let's say that this is my theta, or 45 degrees. The sine is opposite over hypotenuse. That's radical 2/2 over 1. But over 1 doesn't matter, right? So this is it. Cosine adjacent over hypotenuse, it also is radical 2/2. And tangent, do you remember I said a minute ago that tangent is sine over cosine? Well, look, sine is also opposite over adjacent, that's radical 2/2 over radical 2/2, which is just the same thing over itself, that is 1. All right, if we look at the 30, 60, 90, if we look at the 30, here we are at the 30, opposite over hypotenuse is 1/2 over 1, that's just 1/2. Adjacent over hypotenuse is radical 3/2 over 1, which is just radical 3/2. And opposite over adjacent is 1/2 over radical 3/2. And those 2's are going to cancel. And so now we have 1 over radical 3. And we want to simplify, so we do radical 3/3. So our final answer is radical 3/3. So now let's take a look at, well, what about the 60? Okay, same thing, opposite over hypotenuse, adjacent over hypotenuse, and now we're going to do opposite over adjacent. That's radical 3/2 over 1/2 The 2's cancel out and leave with just a plain old radical 3. Okay, these 3 triangles we are going to use and put them into the unit circle. So our next video will talk about what happens when we put those on a unit circle.